Hi, my name is Adam. Welcome back to GodotGameLab. In this video, we'll do a bunch of new stuff like card tooltips, drawing cards, discarding cards at the end of our turn, and tackling turn management a bit too. If you take a look at this project, we no longer have our placeholder cards in our hands, but when I run the game, we start drawing cards from our deck instead. So we can still play the cards like we could before. I can play and gain block, and when I run out of mana, I can end my turn by pressing this end turn button, which will discard all the remaining cards in my hand. And after doing so, for now we'll just restart with a new turn, reset our mana back to 3, draw some new cards, I can still play them, get 10 block for this turn, end my turn, and you can see that the block is resetted for the player, the mana gets reset too, and we draw new cards again. That's a lot of things to do in one video, so let's get started. Okay, so open up the project, and why don't we start with creating the tooltip scene first? So click on the plus sign to create a new scene, and this time we'll use another node, a panel container, as the root node. So search for panel container, double click and rename this to tooltip. Go to layout, transform, and we can resize this to something like 120 by 36 maybe. Zoom in a bit more, and we can anchor this tooltip to the center top of the screen. And also let's not forget to apply the theme as well. So go to theme, quick load, and choose the main theme. Oh, so what happened here? Even though we loaded the theme, we still don't have the panel, the style box we provided applied. Why is that? Well, if you go to the theme and click on it, we can see that we only provided override for the panel, but not the panel container. And those are different kinds of nodes. So we need to add the panel container too. So go to manage items, import items, and we can filter by typing panel container. And we can import the style boxes, import selected. And if we close this window, we'll have the panel container here as a type 2. And if we select it and go to this rainbow icon to the style boxes, we can just quick load the base style box we have for the card. And you can see that immediately this applies this style box to our panel container. Cool. So we can close this theme doc at the bottom, and we can also save this scene. So press Ctrl S, go to scenes, UI, and tooltip.tscn is perfect. And let's add some new nodes next. So under the tooltip, we'll use a margin container. So search for margin container. So we can provide some margin around the borders. And if we go to theme overrides and constants, we can use a margin like 3 pixels. I think works pretty good here. So use 3 in all 4 sides. And under this margin container, we'll add a VBox container next. And you can see the margin applied here. So we have this nice little space between the content and the edges of this tooltip window or panel. And we'll add 2 new child nodes to this VBox container. So click on the plus sign. First, we'll add an icon, which will be a texture rect node. And we can rename this to tooltip icon. And if we go to layout, we can set a minimum size on the y-axis to make sure that it's somewhat tall. We can use something like 8 pixels, but you can change this value to whatever you like. And we can set the expand and the stretch mode. So the expand mode will be ignore size. And we can use for the stretch mode, we can use keep aspect centered. And we can load an icon just to test how this looks like. So I'll use the X for this, and this looks perfect. And if we select the VBox container node again, we can add our final node, which will be a rich text label. And we'll get to the differences between the rich text label and the basic label node later on. But what we do here is we can type in some text to test how this looks like. tooltip description or something like that. And you can see that we need some sort of a minimum size here too. But actually, we don't need to use any specific value here. What we can do is we can go to Layout, Container Sizing, and check this Expand property on the vertical axis. And what this does is it makes sure that the node will fill all the space available on the vertical axis. And that's perfect for us. Then what we can do is we can rename this node to something like Tooltip Text. And if we want to use fancy stuff in our card description, like different colors or waving animation even, we can use BBCode for this. So this is why we use a rich text label node. And we can enable this property, which does nothing on its own, but if we use BBCode in our tooltip description, it will parse it. So for now, that's all the setup we need. And one final thing we can do is we can set these two nodes, the icon and the text node, to be scene unique. So no matter what we change in the future in our UI hierarchy or in our layout for the tooltips, we can still access these anywhere from the scene tree. So right click this tooltip text, press access as unique name. We'll have this person sign here and do the same for the icon. And that's the final thing I wanted to do here. So press Ctrl S to save this scene and we can move on to the coding part. So why don't we go ahead and select the root node, the tooltip node, click on attach script and attach tooltip.gd. And like we usually do, we can remove all the auto-generated code. So what do we do in this tooltip script? First of all, we'll define a new class name so we can access it as a static type throughout the project. Then we'll have an export variable called fade seconds, which is the amount of time we need for the tween animations to finish. Then we'll have two onReady references to our scene unique nodes, one for the icon and one for the text label. Then we'll have a member variable for the current tween because we need to be aware of the fact that we only want to display one tooltip at a time. Then in the ready callback, we'll set the modulate for this tooltip panel to transparent and hide the panel by default. Then we'll provide the show tooltip function where we inject two dependencies, one for the icon texture we want to show and one for the text we want to display for the tooltip. Then we check if we have a valid tween or not, and if we do, we kill the current tweening animation if there's any. Then we'll set the two nodes corresponding properties for the injected dependencies we need. So for the texture rects texture property, we use the icon which is passed into this function, and for the labels text property, we use the string we passed to this function, and then we do the tweening animation. So first of all, we'll create a new tween. Again, you can use any easing or transitioning mode you like. Then we'll call the show function for this node, so it's no longer hidden. And after that, we tween the modulate from transparent to white in the given duration we have in our export variable. We also want to provide a function for hiding the tooltip. So we do the same thing again. We need to check if we have a valid tween, and if we do, we need to kill any animations running. Then we'll call a hide animation function. And what this hide animation function does is actually the opposite we did when we show the tooltip. So again, we'll create a new tween and tween the modulate property from white to transparent in the given duration we have in the export variable. And then after the panel becomes transparent, then we can call the hide function too. And that's all the code we need for now. So we can go ahead and save this with Ctrl S. So before we hook this new scene up, let me show you something first I forgot to set up in the scene itself. So let us go back to 2D view. And if we select the tooltip text node, the rich text label node, and copy this tooltip description to a new line, you can see that the lines are pretty close to each other, and I don't really like that. Imagine if we'll have a card with multiple lines of text for the description, it looks a bit hard to read. So if we scroll down to the theme overrides and constants, we'll have a constant called line separation. And if we check this and start increasing this number, something like 2 looks much better in my opinion. So I forgot to set it, so make sure to set it however you like or however you think is fit. I think for accessibility, it's a much better option here. So let's save this with Ctrl S. Then we can start hooking this up. If we go back to the battle scene, select the Battle UI canvas layer node and instantiate a new child scene, and we'll use the tooltip.tscn. You can see that because we set up the anchoring properly, it already is in the correct place, but we can go to move mode by pressing W. We can move this down a bit, just by a couple pixels. I think it looks nicer if it's not connected to the edge of the screen. Okay, let's save this with Ctrl S. So how do we establish the communication between the hand and the card UI nodes and this new tooltip node we have? First of all, if we go back to the script tab and press Ctrl-Alt-O and search for the event bus, events.gd, if we open it up, we'll need two new signals for this. And those two new signals are card tooltip requested and tooltip hide requested. So for the tooltip request, when we should show a new tooltip, we'll need to pass on the card resource as a parameter. Why? Well, because in the tooltip UI we just created, we need an icon and a tooltip text for our show tooltip function for it to work properly. But for hiding it, we no longer need that resource because we'll just play the hide animation. So that's all we need from the event bus for now. Save this with Ctrl S. So how do we emit these signals? If you think about the circumstances under which we can show the tooltip, what do we need to do? We need to move our mouse over the cards, right? And when we move our mouse over the cards, which state are they in? They are in their base state, right? Because we haven't clicked, we just move the mouse over them. So let's open up the base state script, Ctrl-Alt-O, search for base state, and we need 3 new lines of code. So first of all, when we enter the base state, it can mean two things. We either drew the card or we went back to the base state from another state by cancelling it or maybe selecting an invalid target with the aiming state. Either way, when we enter the base state, we don't want to see any tooltips by default. So what we can do is we can emit this tooltip hide requested signal. Then in the mouse entered callback, if the card is playable and not disabled, that means we hovered over a card which we want to display a tooltip for. So in this function, we can emit the card tooltip requested signal and pass on all the data we need from the card UI's card resource. And finally, the mouse exited signal is a similar situation to when we enter this base state, because if we exited the mouse, we need to emit this tooltip hide requested signal. And that's all there is to it with this script. So we can press Ctrl S to save this. But then we also need to connect our new tooltip script to those two events. Because just because we emit them, it doesn't mean that we'll call the corresponding functions from the tooltip class. So press Ctrl-Alt-O, search for tooltip. And here in the ready function, we'll connect those two signals to their corresponding functions. So for the card tooltip requested signal, we'll connect the show tooltip function. And for the tooltip hide requested signal, we'll connect the hide tooltip function. And that's all there is to it, really. So if we save this and run the game, we should be able to see the tooltips if we hover over the cards. And we do, but there's no text. Why is that? Well, if you remember, we haven't set any tooltips in the card resources. So it's just an empty string, but you can see with the icons that it does work. However, there are some problems. First of all, if I go ahead and drag this card and play it, you can see that the tooltip still lingers on. And that's not really good, right? Because if we play a card, it makes sense to hide that tooltip. So let's fix this one first. How and when do we know that we should hide this tooltip because we played the card? Well, there are multiple places where we could do this, but I think it makes sense to do this in the released state. So if we press Ctrl-Alt-O and go to the released state script. So where do we need to emit this signal? Well, we only care about hiding the tooltip when we have successfully played the card, right? And this happens inside this if statement. So what we can do is we can add a new line saying events.tooltip hide requested.emit. And if we save this script and run the game again, play the block card, you can see that the tooltip is no longer remaining up there after playing the card because we emitted this signal before playing it. Perfect. But still, it's kind of hard to test this with no tooltips properly set up or like with these empty strings. So what we can do is we can update those two cards tooltips to make sure we can see what's going on. So if we go back to the file system And under characters, warrior and cards, double click the warrior X attack resource. We can do something like this for the tooltip text. So for BBCode, we can use these tags like center, we'll center the text horizontally, and we can use different colors, for example, with the color tag. For the full list of tags and techniques you can use with BBCode, I'll link the relevant documentation page downstairs. Before playing it, let's set the block card too. So double click the blocking card. And for the block value, I use a different color, this blue one, for example. And if we go ahead and play the game now, you can see that it looks much cooler, right? We have this red text. The text is aligned to the center. It looks great. Okay, so what else do we need to fix? Well, one minor weird thing is that when we hover over the blocking card and move on to the next one, the ox, for example, if I move the mouse slowly, it looks alright. But if I move the mouse fast, it starts the fade out animation and fades in the other one. And it looks like it's flashing. It's not really pleasant to look at. So how do we fix this? We can add a delay between them. So let's say if we wait 0.4 seconds to move from one card to another, then we won't play the hide animation. And it will look much better without this flashing. So why don't we go ahead and do this? Next. And to do so, we'll go back to the tooltip script. So Ctrl-Alt-O, search for tooltip.gd. And to make this change, we'll introduce a new flag. And we call this isVisible, which is false by default. And we'll change this flag in the show tooltip and hide tooltip functions. So in the show tooltip function, before we even start animating, we already set it to visible. And for the hide tooltip, the same thing. Before we start any animation, we set it to false. So what we can do here with this flag is instead of just calling hide animation straight away, we can create a timer for 0.2 seconds. In this example, I've used the fade seconds export variable. And after that time ellipses, then we'll call the hide animation function. This way, we'll provide a 0.2 seconds leeway to hover over from one card to another. But this in itself is not enough. So what we also need to do is in the hide animation function, we'll create an if check to say if not is visible and indent all these statements one level. So what this does is we'll only play the hide animation if the tooltip is currently not visible. And remember, because we'll use a 0.2 seconds timer here, what can happen is before that timer expires, we can hover over to another card. And when we hover over to another card, this hide animation should play, but it won't because showing the new tooltip will set this isVisible variable to true immediately. And so when this if is not true, we'll skip the hide animation. And with this change, if we go ahead and play the game again, you can see that if I'm fast enough, the two tooltips switch immediately. So there's no weird flashing going on anymore. But if I'm slow, meaning that it takes more than 0.2 seconds to move from one to another, then it will play the animation still. It only skips the animation if I'm fast enough, but I think you should experiment with this value, but I think 0.2 seconds feels fine for this, but you can always tweak it however you like. Cool. And before we move on, I want to show you a really specific and almost impossible to spot bug we have here. So if we go ahead and add two print statements to the hide tooltip and the show tooltip functions and run the game, see what happens. So if I hover over the block card, it says show, and if I exit with the mouse, it says hide. Perfect, right? Mouse over show, and if I start dragging it and release it so it gets reparented to the hand, did you spot that? We still have the tooltip on, which is super weird, right? Because we went back to the base state. And so what happened is we triggered a show, a hide, and another show somehow. So if I go ahead and clear this, see again. So if I start dragging this, okay, I hover over, we get a show. I drag it away, release the mouse. Again, you can see that we trigger two events, the hide and the show after each other. Super weird, right? And if I move the mouse a bit, then it picks up the mouse exited signal, so it gets hidden. How do we fix this real specific, real ugly bug? Well, believe it or not, it has to do with the hand script. So let's press Ctrl-Alt-O, search for hand.gd, and we need to make a change to this card UI reparent requested function. And we'll use two new lines of code. So when we start all this reparenting stuff, before we move the card UI child, we set its disabled property to true. This way, we won't be able to emit the show tooltip requested signal. And then when we're finished with all that reparenting stuff and the child is moved to its original index, then we set the disabled property back to false. But we do this at the end of the frame to make sure that the child is already in its new place. And if we go ahead and save this, with this small change, we should be able to fix that bug. So if I, again, hover over the defend card, you can see that we have a show in our console. And if I drag this over and release it, I no longer trigger another show method, right? So again, release it. You can see that we only have a hide message after the show. This was an almost impossible bug to spot, and it took me forever to find this bug and find a fix to it. So I was super happy to show you. I just want to say that it's okay. Game dev is often like this. I spent like a good 2 to 3 hours on this problem alone, even though it's barely noticeable, right? But it still adds a lot if it works properly. So I'm happy we were able to fix that. And we can move on to card drawing next. But just before we do that, we can get rid of the print statements we used to track down this bug. So if we go back to the tooltip script, make sure you delete this print show and print hide debug messages. And if we save the script, run the game again, then it works and we no longer have the messages on the console. Cool. So now we can move on to the drawing finally. So how do we start the drawing process? Well, maybe the best thing we can do is we can refer back to the architecture for this game. So if you remember, we have the battle node sitting at the very top, which is more or less responsible for turn management. In this video, we won't implement all of the things related to turn management, but we need to start doing them, right? Because when do the player draws their cards? Well, at the beginning of their turn. So we need to be able to start the player's turn. However, be aware that the card drawing itself isn't managed by the battle, but rather the player handler node and the hand node we already have. Another thing to keep in mind is that a lot of different nodes need to have access to the player's stats, the character stats resource. So the first thing we'll do here is if we go back to the 2D view, in the battle scene, we'll finally attach a script to the battle UI itself, which will be an orchestrator for all the UI related stuff we have. So select the battle UI node, click on attach script, rename this to battle UI.gd with lowercase letters, and save this script not in the battle folder, but if we go ahead and browse the folders we have in the UI folder, press create, delete all the auto-generated code, and see what we'll need to do here. So for now, this script will be quite empty, but we'll expand on it as we implement more and more stuff in this video. So for now, we'll provide a class name called battle UI. Then we'll have an export variable for the character stats, and we'll also define a setter function for this. And we have two already references, one to the hand and one to the mana UI. So why don't we reference the tooltip here, right? Because we already have the tooltip added as well. If you think about it, the tooltip works already. It manages everything on its own, so we don't really need to do anything to the tooltip from here. However, we're still lacking the setter function. So in the setter function, we'll do two things. First of all, we'll set our character stats to the new value we have, and then we also inject this new value as a dependency to the mana UI by changing the mana UI's own character stats property to the new one we received in the setter function. And for now, that's all there is to it. Then we can move on and do the same thing for the battle itself, the very top of the hierarchy. So if we go back to 2D view, select the battle node, pick attach script, call this battle.gd, press create, and delete all the auto-generated code too. So what do we do here? Well, first of all, we'll have an export variable for the character stats, and this will be the main place, actually the only one place where we specifically need to provide the character stats, because we will sort of distribute this resource from here to everywhere else in the project. But remember that for the character stats, we still have export variables for all the other bits and pieces in our code. And what that means is that we can test all those bits and pieces individually, but when we don't want to test the game, but run it properly, we'll always override those test values even if they are provided from here. So that's the only one place we really need the character stats in terms of properly playing a battle. Then we'll have a reference to our battle UI as an onReady variable. And in the ready function, first of all, we'll create a new instance from the character stats. And here, unlike anywhere else in the project, I've also added some comments. Because if you think about it, we don't really want to do this in every battle. Because in Slay the Spire, those stats are provided and created on a per run basis. And that means that our health, gold, and deck shouldn't ever reset between battles, right? But now, with our code, it would, because we do this in the ready function of every battle scene we have. But that's not a problem, because the scope of this tutorial series is just simulating one battle. So I just wanted to highlight that this is temporary code too in the grand scheme of things if we were to continue this series. Then we can pass this new character stats instance as a dependency to the battle UI we just set up previously. And this change cascades if you think about it, because the battle UI will assign that very same resource to the mana UI, for example. So this is why I said that the only place we really need to provide a character stats resource is this one. And then what we do is we call a start battle function and we pass on this character stats resource. And in the start battle function, temporarily, the only thing we do is we print out a message that the battle has started. So if we go ahead and save this scene, go back to 2D view and select the battle node, the root node, we can drag the warrior resource to this exported variable. And if we go ahead and play the game, we'll see a print message that the battle has started. Perfect. To actually start the battle though, instead of just printing out the message, we still need a bunch of stuff to do. First of all, we can finally get rid of the temporary card UI scenes we have here. So we can go ahead, select all of them, press delete, and OK. So we can see that our hand is empty. It no longer has any children. However, if you remember, the card UIs also need an access to the character stats, so we can check if they play that specific card or not based on their current mana. So what that means is the hand itself also needs access to the character stats, so we can pass it on to the card UIs. And to do so, we'll need to modify the hand script. So click on the script icon. And for now, the first thing we need is a new export variable for the character stats resource. But also, we need to reference and preload the card UI scene itself, so we can instantiate it from code whenever we draw cards in the future. And while we're here in the ready callback, we can get rid of this code which iterates through all the children and connects the parent property and the reparent requested signals, because we no longer have any children by default. We get the cards drawn from code, so we can remove this piece of code too. Now go ahead and save this script. And if we go back to 2D view, you see that we have a new export variable for the hand script, and we have one for the mana UI too. But if we open up the script for the battle UI itself, we only pass this dependency, but we need to do it to the hand too. So we already have an onReady variable for the hand, but we haven't used it anywhere. So what we need to do is when we receive the character stats dependency from the battle node from the very top, we need to pass this not just to the mana UI's character stats property, but also to the hand's brand new character stats property too. So with that small change, we can save this script. So how do we go about this turn management and drawing and all that stuff? We'll probably need some new events in our event bus, right? So let's open up the event bus by pressing Ctrl-Alt-O, searching for events. And for drawing, we'll start with one new event. I put this in a new group because it's not strictly card related, but rather player related or players gameplay related. And we'll call this one signal player hand drawn, and we'll emit this when at the start of our turn, we have drawn all the cards into our hand. We can save this. And now we can go back to the hand script. So if we press Ctrl+O, search for hand.gd. And what do we need to do here? Not much really, because the hand class itself is just a puppet. We want to restrict the gameplay logic and the turn management logic to the player handler and the battle nodes. But we do need something else. Because if you remember, we deleted a bunch of code from the ready callback. And what that code did is it iterated through all the children, which we don't have anymore, so that's not a problem. But we need a way to add new card UIs from code, because we will draw our cards from our draw pile, and we need to create corresponding card UIs to represent those cards. And also we need to connect the reparent requested signal to our own callback function and set the parent property too, so the aiming animation can work properly. So we only really need one function here, and we'll call it addCard. It requires a card resource to pass in as a parameter, and then what we can do is we can instantiate a new card UI, add it as a child, and then first of all connect the reparent requested signal, set the card UI's card property to the card we received as a parameter, then set the parent to ourselves, and last but not least, set the character stats dependency from our own one. And that's all we need from the hand. We rely on this addCard function in our player handler script. We can work on this mysterious player handler node next. So if we go back to the 2D view, select the battle node at the very top and add a new child with the plus sign or Ctrl+A. We'll use a simple node for this. And double click and rename this to player handler. And I'll drag it above the battle UI. This is really up to personal preference, but how I like to keep my scene tree organized is for 2D games at least. I'll have the blue 2D nodes above everything else. I'll have my UI at the bottom and anything else in between the two. But you can do it however you like. So let's attach a new script to this node, browse the folders and go to... I think it makes sense to save it next to the player. But you can do a separate folder for this if you wanted to, and rename this to player handler.gd with snake case, create the new script, and delete all the auto-generated code. Let's see what we have in this player handler class. So first of all, we'll create a new class name as per usual. Then we'll have a constant called handDrawInterval, which is given in seconds. What do we need this for? Well, when we start drawing our cards at the start of our turn, we don't want all the cards to pop into our hand at once, because that would look weird. So what we do is we create a 0.25 seconds pause between all the card draws. Again, you can experiment with this value later on to see what fits your liking. Then we'll have an export variable for the hand, because this player handler class relies on having a hand somewhere in the scene tree to work. So we'll create this dependency as an export variable to make it easier to assign it in the inspector. Then we'll also have a member variable for the character stats, because we need it for a bunch of different reasons. Then we'll define our own start battle function, which receives that character stats resource as a parameter. So we can set this dependency from the outside. Namely, we'll hook this up in the battle script when we finish it. Then we can set up all the things we need for the battle. First of all, the draw pile will be a duplicate of the current deck of the character. And for the duplicate function, if you pass true as an optional parameter, what it means is that it creates a deep copy of the resource. And the deep copy means that if a resource has another resources as properties, those will be copied too. After that, we shuffle the draw pile. And for the discard pile, it will be empty at the start of the battle, so we'll just create a new card pile and store it as the discard pile. Then we call our start turn function. And for the start turn function, just think about it. What do we need to do when we start a new turn in terms of gameplay? Well, first of all, we'll set the character's block to 0 and reset the mana they have. And then we need to draw as many cards as that character can currently draw. So we have this information available in the character's cards per turn property. Then we can finally move on to implementing card drawing itself. So how do we do this? Well, for a single card, it's pretty easy actually. We call the hand's addCard function, and if you remember, we need to pass a card resource as a parameter to that function. So what we do is we take the character's current draw pile and draw one card from the top of it. A more interesting function is the draw cards function, where we can draw multiple cards at once. So we'll have the amount of cards we want to draw as a parameter. And what we do here is we create a tween so we can actually implement the pause between the card draws. Then we'll start a loop based on the amount of cards we want to draw. And what we do with the tween is we call the draw card function, which is above this one. And then with the tween interval, we make the tween wait hand draw interval seconds, which is the constant we provided at the top of the script. And finally, we connect the tween's finished signal to an anonymous function where we emit this signal we provided earlier, namely the player hand drawn signal. For the drawing, that's all the code we need in the player handler. It's not that complicated, right? Because all the different systems are set up, and basically this is just putting all the puzzle pieces together. And the quick side note here is that a lot of people would use coroutines for this. In Godot, that means using the await keyword. However, using coroutines comes at its own risk, so to say, and personally I prefer to use signals anyways. So this is why I use the tween's finished signal, to make sure that we only emit this player hand drawn event when we finish drawing all the cards. If you're interested on what I mean by coroutines can be risky, I recommend watching this video. I'll have the link downstairs. So let's save this script. And we have all the functionality we need here, but we need to hook this up. Where do we call this start battle function? Well, if we play the game now, you can see that we have a debug message that the battle has started, but I still don't draw any cards. So if we go back to the battle script, Ctrl-Alt-O, search for battle.gd, you can see that in our start battle function, we only print out this debug message. So what we can do instead is call the player handler start battle function, so we actually start drawing cards. So how do we hook this up? Well, we only need to change this print statement, but to be able to access the player handler node, we need an onReady reference to it. So let's reference this player handler node the usual way. And then what we can do is we can take this print statement and switch it out with player handler.startBattle. And if we save this script and run the game again, you can see that I'm greeted with an error message because I forgot to do something again. So what the error message is non-existent function addCard in base nil. So we call this addCard function here, right? We want to call the hands addCard function. And if you remember, we defined an export variable for the hand, which I didn't set at all in the inspector, and this is why we have this error message. So if we go back to 2D view and select the player handler node, we need to assign a hand to this. So I click on assign, select the hand which is highlighted because of the type, click on OK, and when we run the game again, we finally start drawing cards at the start of our turn. Awesome. So now that we have our drawing mechanic in place and everything's working as intended, the last thing we want to tackle in this video is to implement ending our turn as well. And what does that mean in terms of gameplay? So when we end our turns in Slay the Spire, we discard all the remaining cards from our hand. And usually that's where the enemy's turns begin, so they can start performing their intended actions. However, we don't have this enemy action system set up yet. So what we'll do here is we'll implement ending our turns, discarding the remainder of our hand, and then we'll just cycle back to starting our next turn before we hook up all the enemy system in a later video. So just like we always do, we break up this task into smaller, more manageable steps. The first thing we'll do is to modify the UI again. This time we'll be adding an end turn button, so we can press this button when we want to end our turn. To do so, we'll select the battle UI node in the battle scene, click on the plus sign or press Ctrl A, and we'll search for button, and the base button class will be perfect for this. Double click and rename this to end turn button. And just so we can be sure if however we modify the UI later on, we can still access this button from the battle UI script. Let's go ahead and right click on this and access it as a scene unique name. So this $sign appears again. And what we can do is we can change the look of this button a bit. First of all, from the anchor presets, we can select bottom right. So it anchors to the bottom right corner of the screen. Then we can set the text to something like end turn. And you can see that the text is really, really big and the button is really big itself too. So let's assign the theme to this button. So if we go under theme, press the arrow, quick load and load our main theme, you can see that the text changes right away, but we still don't have this usual style box we have for the cards, for the menu UI, for the tooltip too. So how do we assign this to the button? Again, we can do this for just this one button, but to make it easier for our future selves, we can expand it in the theme itself. And to do so, we'll click on this theme resource. And you can see that the buttons are the default black ones. So to override the buttons style boxes, let's go to manage items, and under button, we'll import the style boxes. Click on import selected, close this window, and now we'll have panel, panel container, and button as a third override for our theme. So which style boxes do we want to use? For the normal, we'll quick load the base style box we have. And you can see right away that it changes the button's appearance accordingly. For the focus, we don't really want to change the button's look at all. So in this case, we'll click on the arrow and use a style box empty. For the hover, we'll use the cards hover style box we have. So let's click on the arrow, quick load, and quick load the hover style box. And as for the disabled and pressed style boxes, we can do something a bit different so the buttons feel more interactive. So for the disabled, we can just drag and drop the normal style box we have and make a change to it. So if we click on this and choose make unique, you can see that it's no longer the same file we had here. And if we click on the disabled button style, we can select the background color and make it more transparent, for example. And this would indicate that this button cannot be interacted with. Now if we go back to the theme again, we can do the same for the pressed, but this time we'll use the hover style box as a starting point. And again, if we select this and click on make unique, we can change the appearance. So we can do something like making the border darker. Let's go ahead and try that. So under border, I'll select this color and make it a bit more dark, like so. And if we select the button node again, we can go to layout, transform, and change the size to something like maybe 45. So make it a bit wider and make it like 14 pixels tall. Yeah, that looks perfect. But again, we need to set the anchoring so it snaps back to the bottom right side of the screen. And we can close the theme window for now by clicking on the name again. Let's move this away from the corner a bit so it looks a bit better. I'll go into move mode by pressing W. And while moving, I'll hold shift so it only moves on one axis at a time. And we can do something like this and maybe move it a bit that way to the left. Okay, that looks perfect. So go back to select mode, save the scene. And if we play the game, we can see and test how the button feels. So if I hover over, I get this nice little border change. If I press it, it becomes darker, which feels much more interactive. And that's perfect for the enter button, I think. We can still check the disabled status and how it looks by pressing this disabled checkbox here. So you can see that if I run the game while it's disabled, it has this transparency and I can no longer click on it. Neither I have this hover effect activated. Perfect. So we can uncheck disabled for now. And next up, we'll need new events in our event bus so we can handle ending the turn and discarding all the remaining cards. And to do so, we'll go to the script tab, press Ctrl-Alt-O, and search for events. And here we'll add two new player-related events. One for player hand discarded when we finished discarding all of the remaining cards, and one for player turn ended, which will only be emitted when we press the end turn button in the game. And that's it really, we can save this script. Then the next step is to expand the hands functionality. So let's open up the hand script by pressing Ctrl+O, searching for hand.gd. And in the hand script, just like we did with this add card function, we'll provide two new functions the player handler can use to implement the end of the turn when we discard all the cards. The first of those functions will be called discard card, and we'll get a card UI as a parameter, and all we do is we queue free or delete that card from the scene tree. And then we'll also have a disable hand function which iterates through all the children and sets the disabled property of that card UI to true. So why do we need this? Well, if you think about it, at the end of our turn, we'll discard all of the remaining cards from our hand. And just like we do with the drawing, we'll provide an interval between the two discards so it looks more natural and they won't discard all at once. But doing this takes time, and we don't want the player to be able to interact with those card UIs while they are being discarded, right? So we can just call this disable hand function to prevent the player from interacting with the cards while the discarding animation happens. And that's all we need for the hand script. So save this with Ctrl+S. Then we need to hook up the end turn button somehow, because if you remember, I kept pressing it, but nothing happened, right? So where do we do this? Well, we said that turn management is the battle node's responsibility, but I still think that ending the turn is very close to the UI because the only way to do so is to press this button, right? So I think it makes sense to code this in the battle UI script rather than the battle script, but you can fight me over this one. There's no one proper way to do this. If it makes more sense to you to do it there, then sure, go ahead and do it there. It's not a problem. But for now, I will just do it in the battle UI script. So press Ctrl+O, search for battle UI. So before we do anything, we'll need an onReady reference to our end turn button. Then in the ready callback, we'll do two things. We'll connect the event bus's player hand drawn signal to our own callback function, and the end turn button's pressed signal to a different callback function. So why do we need to connect to the player hand drawn signal? Well, let's think about the possible interactions for a second. Let's say that the end turn button is enabled by default. And in theory, when we start drawing our hand and the animation is still going, I can still press the end turn button and start the discarding animation before the drawing animation has finished. And this can lead to a whole lot of unexpected behavior, bugs and errors, so it makes much more sense to totally separate those two. So by default, the end turn button will be disabled. We start to draw our hands and we only enable the end turn button to be pressed when we already drawn all of our cards. And to do so, the only thing we need in our callback function is to change the end turn button's disabled property to false. We'll handle the discarding itself in the player handler script. So here that's all we really need to do. And for the other callback function, when we press the end turn button, we'll disable the end turn button so it can be pressed again until we draw our next hand next turn. And we also emit the player turn ended signal from the event bus. And we'll connect this signal to our player handler to let it know that it should start discarding our hand one by one. And that's it for the battle UI script. And our final task in this video is to implement the discarding in the player handler script. So let's open it up with Ctrl+O and search for player handler.gd. And here we'll add a lot of new stuff. The first of them is a new constant for the hand discard interval, which works really similarly to the hand draw interval, is the amount of seconds between the two discard animations. Then the next is an end turn function, which will hook up to the event which is emitted when we press the end turn button in the game. And what we do here is, first of all, we call this new disable hand method to prevent the player from interacting with the cards while discarding, and then calling the discard cards function. Before we create that discard cards function, however, we'll change the draw card function too, and before drawing a new card and adding it to the hand, we call the reshuffle deck from discard function, and after drawing the card, we'll call the same function too. Why do we need this? Well, because if you start drawing cards one by one, it can happen that the draw pile becomes empty. And when it does, what we do in this game, and in Slay the Spire 2, is we reshuffle all the cards from the discard back to the draw pile. And in theory, this can either happen before drawing the card or after drawing the card. Then we can do that discard cards function we talked about earlier when ending the turn. First of all, we'll create a new tween, similarly to when we implemented the draw cards function. Then we iterate through all the children of the hand node, and for all of them, we do 3 things with the tween. First of all, we add the current card to the discard pile. Then we call the hand's discard card function. Finally, we wait for hand discard interval seconds before discarding the next card. And when this tween finishes, then we can emit the player hand discarded signal from the event bus. And later on, when we implement enemy AI and logic, this is where the enemy turn will start. And finally, we still need that reshuffle deck from discard function. And first, before starting all that reshuffling business, we'll check if the character draw pile is empty or not. Because if it's not empty, we don't need to reshuffle anything. We can return from this function immediately. So with this, we make sure that we only reshuffle if it's really needed. And then what we do is we take the top card from the discard pile and add it to the draw pile. And we do this in a loop until the discard pile becomes empty. And then finally, after the loop, when the discard pile has been emptied and added back to the draw pile, we can shuffle the draw pile to randomize the order of the cards. And our player handler script is basically ready. We can save this. And we're still not ready, even though I promised we were, because we still need to connect all these pieces together at the very top in the battle scene. So one final time, come with me to this battle. Ctrl-Alt-O to open up battle.gd. And what we do here is we connect 2 signals from the event bus. First of all, when the player turn has ended, we'll connect that signal to the player handler's end turn function, which we coded just now. And for the player hand discarded, so when the discarding animation finishes, we connect that to the player handler's start turn. Mind you that this is just a temporary piece of code, because in a later video, this is where we want the enemies to execute their intended actions, right? But for now, to make sure we can draw and discard cards, we'll do it like this. So if we save this script and run the game, we should be able to draw our cards, play some of them, then press the end turn button, discard the remaining cards, and then start our next turn, reset our mana, draw new cards, we can play them again, end our turn, discard them, draw them again. But if we take a closer look, we still have 2 more problems. One of them is when I play a block card, and play a block card again, and end my turn, you can see that the block isn't resetting at the start of my turn. Why is that? It can be the script, right? Because if we take a look at the player handler script and go to the start turn function, we reset the block to 0. So why isn't it resetting? If I play a block card again and then my turn, you can see that it's not going to reset. Why is that? Unfortunately, it has to do with temporary code from the past. So if we go to the player's script, you can see that for the character stats setter function, we call this value that create instance. And if you remember this create instance function, it creates a duplicate of that resource. And that's not really good because we'll have 2 different resources. One that we play the cards for, and one that displays some kind of stats. And that's not at all what we want. We want to use the same resource, right? So if we go back to the player script, we can delete this create instance from the end of this character stats value. And if we save the script and go back to 2D view, you can see that we assigned this warrior stats to our player to test it earlier. And this is what became duplicated when we ran the game. So instead of creating a duplicate there, what we can do is we can hook it up from the battle node. Because if you remember, we said that this is the one place where we want to set up the character stats for real, and we can sort of distribute this dependency throughout the project. So if we go to the battles script, we can very quickly grab an onReady reference to our player node, and in the ready callback, we can assign the stats from the one duplicate we create here, just like we do with all the other components of the game. So if we save this and run the game now, and play some block cards, we can no longer transfer, at least visually, block from one turn to another, but it gets reset all the time. And while we're here, I can show you another bug. So if I go ahead and play some cards and play some turns, eventually I will run into an error. Why is that? It says that when we try to draw a card in the player handler, here, we draw nothing. Why can that be the case? Let me show you that with the debugger. We'll have this character resource here, so we can actually inspect what's going on here. We have the deck, the discard, and the draw pile as well. You can see that we have 10 cards in our deck, which is perfect because that's our starting deck. But if I go back and take a look at the discard and the draw piles, you can see that the draw pile becomes empty. It's a size of 0. If I go back and take a look at the discard pile, it's empty too. How on earth did we do that? Well, there's one teeny tiny problem we have here. So when do we add cards to the discard pile in our code? You can see that we have this callback function here, which calls character.discard.addCard, which is perfect because when we discard our cards at the end of our turn, we want to add them to the discard pile, right? Perfect. But if I select this discard keyword and hit Ctrl-Shift-F to find all the occurrences throughout the project, you can see that we have a bunch of stuff, but we don't really have. We have discard.addCard here. This is the same one I was showing you earlier, this line. But that's it. That's not the best, right? Because we don't just want to add cards to the discard pile when they remain in our hand at the end of the turn, but when do we also want to add cards to the discard pile? That's right, when we play the cards. So what happens is after playing a bunch of cards, we just delete them as card UIs, and we never add them to the discard pile for the player to reshuffle. And this is why after a while we get into an error message saying that our deck get emptied, both the discard pile and the draw pile. Fortunately for us, finding out why the bug is happening is way harder than actually fixing it. All we need to do really is in the ready callback, we connect the event bus's card played signal to our own function called onCardPlayed. And in this function, if you remember, we get a parameter, which is the card that has been played, and we can just go ahead and add this to the discard pile. And with this quick fix, if we rerun the game again, no matter how many cards I play, the stats get reset. And after playing a bunch of cards, one after another, I no longer get this error message. By now, we would already have that error message we had earlier. So everything works perfectly. We can play our deck infinitely, in theory. And that's it for this video. And I'll see you in the next one. Bye bye.